All right, me hearties, it's time for us to look at some rational numbers. Today we'll be looking at section 2.7, rational numbers, and it can be found on page 102 in your textbook. I hope you enjoy today's lesson. By the way, remind me to tell you a joke about rational numbers in class. It's a funny one, if you understand math, that is. You might not like it. I think it's funny. Remind me. I'll tell it to you. Anyway, let's begin. First, we need to understand what a rational number is. Well, a rational number is a number that can be written as a quotient of two integers, where the divisor is not 0. And you're kind of like, what? What that means is, a rational number is any number that you can write as a fraction, okay? Any number that you can write as a fraction where the bottom number, the denominator, the number you're dividing it by, is not equal to 0. So any number that can be written as a fraction or a division problem where the bottom number is not 0 is a rational number. That might sound like a weird definition, but we'll take a look at what that includes. Okay? So some examples, these aren't problems to work out, these are just examples of what rational numbers are. All of these are rational numbers. 2/5, a fraction. A terminating decimal that ends, like 0.5. Negative numbers, like -11. Repeating decimals, like 0.7 repeating. Remember, that's what this bar means above it, that the 7 repeats. And mixed numbers like 5 and 7/8. All of these are rational numbers because there is a way to write them as fractions. The last section we looked at how to write decimals, both ones that are terminating, how to write them as fractions. I told you there is a way you can write repeating decimals. We're not going to go over that method yet, but you just need to take my word for it. There is a way that you can write this as a fraction. There's a way. Whole numbers, even whole negative numbers, can be written as a fraction. You just put them over 1, so -11 divided by 1. Mixed numbers you could convert to improper fractions, and fractions are already fractions. So all of these have ways that you can turn them into just fractions, okay? Now some people might wonder, okay, so isn't that all the numbers out there ever? No, there are a few numbers that cannot be written as fractions. They're numbers that, and if you want to write this down, you don't have to, this is just extra for you, but numbers that never end, meaning they don't terminate, and they never repeat, those are not rational numbers. Those are the numbers we're not including. We're not going to look at any of those today. They're called irrational numbers, but we're not going to look at those today. But to give you an example, pi is an irrational number. It's 3.14, and the numbers keep going. It doesn't have a pattern that repeats. It never ends. So there's no way to write it like this, and there's no way to write it like this, and that's what happens. There's other numbers like that too, and like I said, when we touch on irrational numbers, we'll look at those more often, okay? So let's get started with today's lesson and what we're going to be asked to do. So, we're given two fractions right here, okay? We're given two fractions, and in this section, we're going to compare these fractions. We're going to find out which one's greater than the other. Now, we've done stuff like this before. The only difference is you'll notice that these include negative fractions. It's important to remember something. If I'm ever told to compare a positive number and a positive number, well, whichever one is bigger, that's the greater than. So that we would say, like, if I had, I'm just going to write over here as an example, another example. If I was told to compare 2 and 5, which one's greater? Well, 5 is obviously greater, okay? When you're told to compare two negative numbers, It's the smaller number that is actually greater. I did show you in class how we could convert both of these to decimals to find out for sure, or we could find a common denominator to know for sure. But class, I did tell you we could use common sense. If the fractions aren't super close to each other, we should be able to easily tell which one's bigger and which one's smaller. This is 1/3. That is less than 1/2. How do I know? Well, half of 3 is 1.5. And that's less than 1.5. So the 1 is less than 1.5. So this whole thing is less than a half, while this over here is more than a half. Hopefully you can see that 1/3 is less than a half and 4/5 is more than a half. So this one is more, but it's negative, and this is negative. So which one's actually greater? Negative kind of works in the opposite way. So this fraction over here is actually the greater fraction. That's important to remember, okay? So let's just box this in so we can see that. Let's box this in over here. I would like to make one more example just to make the point. I think this is obvious, but I'm going to go ahead and say it. If you're ever told to compare a negative number like -52 compared to 3, I would hope you instantly know which one's greater. I mean, one's negative, one's positive. The positive is always greater than the negative number, okay? So that one is always greater. So that just covers some things we might be asked to do when we're told to like compare the numbers. Tell me which one's bigger, blah, 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 blah. So like I said, I hope you already knew how to do this. I hope this one was obvious. We do need to be reminded about some things like this, especially when you have to keep up with negative numbers and fractions or decimals in your head. It can get a little tricky. Let's look at another example of what we might be asked to do in this section. Order from least to greatest. Now this is a tricky section, so you need to really pay attention to this. And like I said, if you get lost or get confused, pause the video, rewind it, watch the whole thing through, and then go watch it again maybe. But if you still don't get it, put a question mark by it and ask in class, because some of this stuff is a little tricky at first. So for example 2, we're told to order from least to greatest, 1/2, negative 0.3, negative 2/9, and 1.1. Okay, I hope a few things stand out as obvious to you. I hope you notice that we have a positive and two negatives. So I hope we know that these two, I don't know which one goes first, but one of these two is going to be first because they're negative, so they're obviously least. Well, the positives are going to be on the greater side. So if we want, we could already go ahead and put it like this and say, well, I know this is the biggest, and this is the second biggest. I know that 1.1 is the greatest, and 1/2 is the second greatest. We could convert this to a decimal so you can see that, but I really do hope that you all know that 1.1 is greater than 1. And I would hope you would all know that 1/2 is less than 1. So I really hope that's obvious to you. If it's not, you really do need to see me so we can, talk about this and work on this. Now the question is, which one here is smaller? Now these are close enough together where I honestly don't recommend risking trying to figure it out on your own. The guaranteed way to figure it out is to take all of your fractions and convert them to decimals. That's the easiest way. We could try to make them both fractions, but then there's a chance we have to find a common denominator, and that just makes more work. So instead of us having to do 2 or 3 steps, let's just do 1, okay? Let's take this, and we're going to do a little work over here and convert this to a decimal. So I'm going to have 9 into 2, okay? I'm going to show you a few tricks about this. Let's take a look. So I have 9 into 2. That can't work, so I got to put a decimal. And I put my 0. Okay? Then what do I do next? 9 into 20. Well, it goes in there 2 times. Multiply back, you get 18. And you could go ahead and, subtract and figure out what is exactly going to be. But you don't have to do that. Stop and realize something. We have 0.2. And remember, this is negative. So we have negative 0.2. It's going to have some other numbers after it. But notice, we have a 0.3 right here. A negative 0.3 and a negative 0.2 something. It doesn't matter what comes after that. You should already better know. Like if these are both positive, we would instantly know that the 0.3 is greater. Okay? Doesn't matter what comes after the 0.2. It's 0.2 it's not going to be bigger than 0.3. Now, because they're negatives, the opposite of that works. So since if these are positive, this looks like it would be bigger, it's actually smaller because it's negative. So you can go and write negative 0.3, and then you can put negative 2 over 9. Okay? I'm not trying to confuse you. I'm trying to point out that if you use a little common sense, you don't have to do all the work, because we're not told to convert this. We're just told to figure out which one is. And if you do just this work right here is enough to know that, yeah, that one's going to be smaller, that one's bigger, and then we know the rest, okay? So hopefully you figure that out. All right, let's take a look at the next stuff that we'll be doing. Here we have 6 over 11, and here we have negative 2.2. We have, what is this right here? This would be what? 0.545 and then 1/2. Obviously, you should be able to do one of these numbers right away. You should be able to go and say, oh, there's a negative, and the rest are all positive. So this one is obviously the least. So you can go ahead and put that one first. Boom, you got that one done, okay? Now you just gotta figure out how the rest of these work. Well, I have 1/2 right here. Once again, I hope you can look at this. Remember 1/2 as a decimal. 1/2 as a decimal is equal to 0.5. So obviously 0.5 is less than 0.545. And let's take a look at 6 and 11, 6 over 11. Is 6 over 11 bigger than 1/2 or less than 1/2? Well, what's half of 11? Well, that would be 5.5. And 6 is more than that. So this right here is just a little bit bigger, just a little bit bigger than 0.5. We don't know how much bigger. We just know it's a little bit bigger. So I could say my next number is this number. So I'll put a comma and 1/2. The question is, which one's the biggest, this one or this one? We've already eliminated this because we know that it's over here. Question is, which one's next? Like I said, convert to a decimal. Easiest way to do it. So again, we come over here to do some scratch work. 11 into 6. We put our decimals, put our 0. That will go into that 5 times. We have a 5. Just like over here, we have a 5. Not good enough yet. Multiply back. We get 55. We subtract to get 5. We bring down another 0. Multiply, go in there 4 times. Looks the same as right there. Multiply back. What do we get? We end up with, what do we get? We get 44, and we subtract, and we get 6, and we bring it down again, and we're gonna get 60. And doesn't that go into that? We've already done that 5 times. Sorry. And it doesn't 11 go into 65 times, and that's 55. Does anyone notice anything here? Aha, this creates a repeating decimal, which means this thing is going to be 4 to 5, 4, 5, 4. So it keeps going. So which one's bigger? Well, this one has 5, 4, 5, but then this one stops, but this one has a little bit more. It's got the 5, 4, 5, 4, 5, 4, 5. You get the point. So this number is actually slightly bigger, which was this fraction right here. So the next number is 0.54 5. And then the biggest one is 6 over 11. And that is how that works right there. Remember, questions, write them down.